Hello everyone, this is the lecture for section 6.1, graphs of sine and cosine functions. So at this point in the class, right, we've learned what the sine function is and the cosine function is, right? We know that the cosine gives us the x coordinate, right? And the sine gives us the y, right? But now, right, we're going to start throwing down sines and cosines uh, on a graph. What do they look like? And as you remember from when we did lines and parabolas and absolute values and square roots, there's certain things that we can see from the function that'll tell us something is going to happen in particular with that function when we do it on a graph. Okay? And we're going to do that for sine and cosine. Okay? But first, I need to show you guys how these look like. Okay? So, the first thing I want everybody to do is go and grab your unit circle, okay? Because all of these values that I'm about to spit out, they're from the unit circle, okay? So, if you've got your unit circle in front of you, right? What I'm going to do is I'm going to fill in this big huge table. And it's going to be a table of values, just like I did with every other function that I've ever shown you, right? Okay. So, when x is 0, notice what the x is here, right? I'm plugging in inside of sine, right? And notice that all of these, whoa, notice that all of these are angles, right? And notice that they are in the radian measure, okay? So just, like I said, you've got to start getting comfortable with it, okay? Okay, so the very first angle I'm going to use is 0 degrees, okay? The sine of that is 0. That's what your unit circle says, right? Okay, we're going to keep going. When x, your angle is pi over 6, your y is 1/2. That should be from your unit circle, okay? When it is pi over 4, the square root of 2 over 2. For pi over 3, that is the square root of 3 over 2, okay? When your angle is pi over 2, that is 1. 2 pi over 6, right? Actually, this is supposed to be pi over 3. My apologies. Okay. Square root of 3 over 2. 3 pi over 4, that's going to be root 2 over 2. 5 pi over 6, 1/2. Pi is going to be 0. So this takes us at least halfway across the unit circle. So if you have your unit circle, right, here's my nice little copy, right? We just did this. We went all the way around to here. We went all the way up to here, right? Okay. There are 2 more points that are left, right? That's going to be -1 and 0 for 3 pi over 2 and 2 pi. Okay. That completes our unit circle. Okay. Now, for this, I know I skipped a bunch of values way back here, right? We don't entirely need them, okay? But know that they are sort of similar to what's right here, okay? Now, I want to slap this on an XY axis, okay? So let me scroll down a little bit. Let me actually get my keyboard. There we go. Okay, I'm going to scroll down a little bit and scroll out a little bit so that we have the graph and the values. There we go. Okay, so I'm going to go ahead and graph all these points that I gave you right up above. Okay, so for 0, your sine of x is going to be 0. So that's right here. Actually, let me thicken up that point a little bit. There we go. For pi over 6, it's going to be 1/2. So right there. For pi over 4, which is about halfway through right there, it's going to be root 2 over 2. So right there. Pi over 3, that's going to be like really, really close right there. Pi over 2 is now 1. Hopefully you guys see this shape happening already, right? For 2 pi over 3, it comes back down. It starts to drop, right? 3 pi over 4, which is about right here, I think. About that point right there. 5 pi over 6, that's going to be 1/2. Whoa. So that point should actually be back here. That was right the first time. And then at pi, it's going to be back to 0. Okay. Hopefully you guys see this shape happening already. It goes up, it hits there, and then drops. Okay. And then we have 2 more points way back here that I'm going to put down. Okay. At 3 pi over 2, it's going to be -1. 3 pi over 2, -1. Okay. And 2 pi, 0. Bam. Okay. So hopefully you guys see what's happening. It's doing this thing. Let's connect the dots first. There we are. That is the sine function on an xy axis. Okay. So just to point out, hopefully you guys see this, the real important points are these 5 right here. I'm going to go ahead and highlight them on the graph themselves too. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay? And the reason why I say those are the most important points is we're going to be able to grab those points and translate them so that we can graph all the transformations that show up in sine and cosine. Okay? That's it. That right there is the sine graph. Okay? Next one is cosine. Okay? We're going to do the exact same thing. Okay? So when you do cosine, right? Cosine, when your x variable is 0, the cosine for it, right, that is going to be 1. Again, from the unit circle, right? Okay. Pi over 6, root 3 over 2. Pi over 4, square root of 2 over 2. Pi over 3 is going to be 1/2. Pi over 2 is going to be 0. This is, again, supposed to be pi over 3. -1/2. 3 pi over 4, negative root 2 over 2. 5 pi over 6, negative root 3 over 2. And then pi is going to be -1. So again, just like before, here's my unit circle, right? We just went up to right here. We went halfway across, right? And then there's 2 more points that I have to fill out, 0 and 1, just to expedite the process here, okay? So again, I'm going to do the same thing that I did here for cosine, the same thing as I did for sine, okay? So at 0, my y value is going to be 1, okay? And then it's just going to start dropping, right? So it's going to be root 3 over 2, so pi over 6 is going to be root 3 over 2, maybe right there, right there, square root, pi over 3, oops, pi over 4 is supposed to be right here about. Pi over 3 is going to be 1/2, right? And then pi over 2 is going to be 0, so that's going to be right there. 2 pi over 3 is going to be -1/2. 3 pi over 4 is negative root 2 over 2, so maybe about right there. 5 pi over 6, negative root 3 over 2 right there. And then at pi, it's going to be -1. Let's connect the dots. Hopefully you guys see the squiggle, right? Okay. Okay, the last 2 points, 3 pi over 2, right there, and then 2 pi, which is going to be 1 again, right? So hopefully you guys see, I mean, you can fill in the points if you want to, but it's not really necessary, okay? I'm just doing it sort of for the teaching sake of it, right? Again, 1, 2, 3, 4, 5. Those are the 5 points that are most critical when we graph sine, cosine, and cosine, right? There, 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 and there. Okay. This is vanilla cosine. This is vanilla cosine. Okay. All from the unit circle. There we have it. That's sine and that's cosine. Okay. So now let me cover some key characteristics of both the sine and cosine graphs. Okay. Okay. So what we know automatically, right, is that we can plug in any values we want for each one of these, right? So we know that the domain of each function is going to be negative infinity to infinity, right? There is no restriction on the angle we can plug in, right? And the range, notice how it bounces in between +1 and -1 for both of these, right? So in the range is going to be from -1 to +1. Whoa. And close brackets because it does actually get to +1 and -1. Okay. These kind of functions are called periodic functions. Okay. Uh, periodic means that it repeats. Any function that repeats itself after a specific amount of time, we call periodic. Okay. One more thing that we need to define when we talk about a periodic function is what's called its period. Okay. Uh, in this case, a period is 2 pi. So if you remember, 2 pi is 360 degrees, right? After we pass 360 degrees, right, all of our values start to repeat. Hence the reason why we say our period is 2 pi. Okay. A couple more things about sine and cosine. Since there is no restriction, for the angle that we can plug in, right? This sine and cosine graph, the squiggle just keeps going. It just keeps going on either end, right? It just doesn't stop. It just keeps squiggling on and on and on and on. Okay. Okay. Sine, if you remember from chapter 5, right? Sine is an odd function. Okay. So it is symmetric about the origin. And the cosine is even. So that is symmetric about the y-axis. Okay. If you guys remember what that means, right, is this, that for, let's actually start with cosine first, right? I can rotate it along the y-axis like this, right? And I get the same graph. That's what it meant to be even. Okay. For odd functions, it is symmetric about the origin. So what that meant was this, that I was able to rotate it this way about the y-axis and then rotate it this way about the x-axis. Sorry, rotate it this way about the y-axis and this way about the x-axis, and I get the same graph. Okay, that's equivalent to saying I can flip it along the x-axis and flip it along the y-axis, and I get the same graph. Okay, I know we haven't done much in terms of that, but it's the same thing. It's the same thing that we did from chapter 1. Okay. All right. Here comes the fine. Here comes the fun stuff. Okay. Variations of sine and cosine. Okay. I If you guys remember from chapter 1, right? I would give you guys I give you all your functions, and I told you guys this is what this does, this is what this does, this is what this does, right? Uh, for sine and cosine, for all your trigonometric functions, exactly the same thing happens. There is a couple of exceptions, though, and that's what I'm going to cover here, okay? Things do change a little bit once we start talking about sines and cosines, okay? Okay, so all of those squiggly graphs that we have, okay, they are called sinusoidal. They're called sinusoidal graphs. Let me actually write it correctly, huh? Sinusoidal. That's a D. There we go. They're called sinusoidal graphs. Okay? Okay. So now, you guys hopefully can see that there's parts here that I need to cover. There's a plus or minus. Whoa. Come on. I chose a highlighter. There we go. There's a plus or minus. There's an A. There's a B, right? There's a C, and then at the very end, there's a D. Oh, well, I know I chose purple. There we go. And there's the D. Okay. All of these things do different things. Okay. And they show up on their graph. Okay. So let me start off with the first one. Amplitude is given by the A, the same A that's up here, these. Okay. Uh, when we talk about the period of a function, right? You remember what a period is. It's the distance before it starts to repeat. Okay. The period of a vanilla sine and cosine graph is 2 pi. Okay. When the b value, when this b value is something else other than 1, then we have to recompute our period. In that case, the period is given by a value, by a variable t, and it's going to be 2 pi divided by b. Whatever that b is just gets put on the bottom and you divide it out. Okay. A nice warning here. Okay. You will have to get comfortable with fractions. You will have to be very comfortable with fractions at this point. Okay. I'll show you guys why in a second. Okay. Okay. You guys remember a horizontal shift? So instead of calling it a horizontal shift, when we talk about sinusoidal functions, we call it a phase shift. Okay. This basically means we're going to pick up the graph and move it left to right. Okay. And if you guys see right here, it's that C and that B that's right there that we're going to use. In particular, it's going to be C divided by B. And it's going to go off of the same rules that it did from chapter 1. If this value right here, if that is a negative, you're moving it toward the positives. If it's positive, you're moving it toward the negatives. Okay? Okay, there's one last variable that I've haven't covered yet, and that's D. That's what we call the midline. This also doubles up as our vertical shift. Okay, so the vertical shift is an amount D, right? Whatever that D value is, that's the amount that we move it up or down, right? And this also gives us what's called a midline. Okay, and that the equation for the midline is going to be Y is equal to D. Okay. So there we go. I think that explains it all. That's all we have. I think there's only one thing that I didn't really explain, but I think you guys know what this does. The plus or minus is just your vertical flip, right? But the rest is good, right? We know what the A does. We know what the B and the C do. That gives us our phase shift, our horizontal shift, right? And then we know what the D does. It gives us the vertical shift, right? All right. So now, how does that all look like here, right? So suppose we had a sine graph. I'm going to do the sine graph as the example, right? The sine graph, right? The phase shift, this thing. The thing that grabs this graph and moves it left to right, right, is going to be the C divided by the B, okay? When we want to know the distance from beginning to end, before it starts to repeat, so I'm talking about this distance right here, from right here all the way out to here. So if I want to find this entire distance, from there to there, right? That is given by that value t, 2 pi over b. Got it? Okay. This right here is what we call our amplitude. So I'm going to give it a nice thick pink arrow in both directions. So it's basically, you guys see that there's a line that sort of splits the graph in two. Okay, so let me draw that line down right now too. Okay, hopefully you guys see that purple line that's going straight through the middle of it all, right? Okay, that right there, that line, that purple line, is what we call the y equal d, or the midline, right? That's what slices our graph in half, okay? And from that midline, right, you guys see how the graph sort of bounces up an amount and down an amount. That is what we call our amplitude. That is our A, okay? And there you have it. That's it. This is sort of the anatomy for a sine graph and a cosine graph. Okay, so now let's do an example. Let me scroll in for a little bit. Oh, come on. It even does it at home. There we go. All right, so I know the answer's there, right? But we're going to try and pick out the stuff that we need. Okay, so I know the answer's there. Bam, bam. I give it to you. That's fine. That's fine. Okay, but we're going to pick it out. We're going to pick it out as if we didn't know it was there. Got it? Okay, so looking at this thing, right? Hopefully you guys see the easy stuff, right? Is the amplitude and the midline. So let's go ahead and do amplitude, and midline. Okay. Hopefully you guys see that the midline is right here, right? And that's at y equal 1. So automatically we know something already. This is going to be our value d, right? Our midline, or sorry, our amplitude is this right here, right? And we're going to look at the physical distance from the midline to the top or from the midline to the bottom. Got it? So that's from here to here, right? The midline's at 1, right? The amplitude's at 4, so that's a distance of 3. That makes A, whoa, wrong color, A equal 3. Okay? All right. Our period now. Our period, hopefully you guys see, it's given by this arrow right here. It's given by this. You guys see that from here. I'm going to actually highlight the section that I'm going to be very concerned with, right? From here all the way down to right back here. And actually, I'm going to do it in highlighter orange so it stands out a little more. Well, you guys see that? You guys see that little section all the way from here? I'm going to do it in orange now. From here to here. That is the distance, right? That is the distance that our sine graph that's here, right, starts and stops. Outside of this distance between those two orange points, right, it starts to repeat. Okay, so then that means our period, our t, is from 0 to pi. So the distance, the overall distance where it, a unique squiggle, right, a unique squiggle is pi. Okay, now there's something else that we got to do. Okay, I want to actually, hopefully you guys see something here already, right? I've already explained, let me do it in the pink here. I already explained the 3, that's your amplitude, right? And the plus 1. Okay, how do we get this 2, right? We know that the formula for a period is 2 pi divided by b, correct? From the previous page in our notes, right? We solved this out for b. So then if you guys remember, so let me write it out over here. I have now pi is equal to 2 pi over b. I can grab my pi and make it over 1. I can grab anything I want and put it over 1. This looks like something I can cross multiply by now, right? So bam and bam. Okay, so then this yields pi b is equal to 2 pi. I want b by itself, so divide by pi. Divide by pi. B is equal to 2. And we are done. Right? There is the 2 that's missing from our equation. Got it? Okay? Last thing, phase shift. Okay? So notice that this section that I've got highlighted in orange, right, in the highlighter orange, we didn't move it at all. It just sort of compressed down into pi. Does that make sense? We didn't physically pick up the sine curve and move it left to right. Make sense? Okay. So that means my phase shift, right, my c divided by b has to be equal to 0. Okay, I know that b is equal to 2, so c divided by 2 is equal to 0. C's got to be also equal to 0. Now we are completely done. So we know this, right? Our amplitude is 3, our midline is 1, our b is 2, and our c is 0. Okay, that's how we get both of these equations. Okay, this is us really reverse engineering our graphs. Okay, just the same as how I've been making you guys do it on the tests, how I've been making you guys do it in your homeworks. We are sort of reverse engineering some of this stuff to find the values that we need to fill in our function. Okay, all right. This is going to take us a long time. So I've got a couple quick checks here. I want everybody to try them in the class. Okay, like this is going to take us a long time. Okay. Okay. But what I want now to do is graph some of these out by hand, okay, just using the knowledge that we have from the last couple pages. Okay. All right. So let me actually zoom out a little bit so I have enough space. There we go, from below. I want to graph this function right here. Okay. We know now, right? This is going to be a plus or minus cosine, right? Plus or minus, let me actually write the letters out. A cosine bx minus c plus d. There we go. Plus d. So it's one of these. Okay. Now, hopefully you guys recall, vanilla cosine is going to do something like this. It's going to something like that, right? Okay. I like to. This has happened multiple times during class, right? Vanilla sine is this one. Okay, we call that one squiggle. A lot of people just call it squiggle. And then we have this one. No joke. People call this one Karate Kid. Okay. Why? I don't know. That's just the way the cookie crumbles, I guess. Okay. Okay, now we know what we want to graph. We know it's going to be a Karate Kid. It's going to be one of these. Okay. But now we have to fit it in right in our axes so that all the critical points are present. Okay. So hopefully you guys see already. I'm going to write the stuff down here, right? The amplitude for this function in the yellow is going to be 2. That is done. Okay. The midline. Hopefully you guys see how simple some of this stuff is, right? The midline is going to be y is equal to 3. Okay. Here comes the hard stuff, right? The period. The equation for the period is going to be t is equal to 2 pi divided by b. We know what b is. That's going to be our pi over 2. So then that means 2 pi divided by pi over 2. Okay. Hopefully you guys, remember how I said just now, right? You got to be comfortable with fractions, right? So I have this, right? 2 pi divided by pi over 2. That is equivalent to 2 pi divided by 1 divided by pi over 2. I'm rewriting here a fraction of fractions as the division of fractions, right? If you recall what to do with this one, right, I can flip the second one, right? I can flip the second one uh, and make it into a multiplication. So 2 pi over 1 times 2 over pi. If you guys see what's going to happen here, the pi's cancel, and it's just going to be 2 times 2. This is going to be equal to 4. So 1, 2, 3. Okay? All right. Last thing that we need to sort of figure out is our phase shift. Okay? Our phase shift is going to be C divided by B. And that's going to be the C and the B that's right here. So C is going to be pi divided by B, which is pi over 2. Okay? Pi over 1 divided by, I'm doing the same thing as I did before, pi over 2, which is equivalent to pi over 1 times 2 over pi. And that is going to be equal to, notice that the pi's cancel again, okay? Gone. 2. Okay? Okay. Here we go. So remember, when we did the phase shift, right? It's opposite of the sign still. So if this is positive, I am moving it toward the negative. Got it? So I'm actually going to be picking up my graph and moving it backwards toward the negatives by 2. So this is something that it's not in your textbook. I'll give you guys that. It is not in your textbook, but it helps a lot when having to graph this thing out by hand. It keeps your thoughts straight a bit eventually, ultimately. Okay. So this is what I like to do. Okay. My graph is going to start based off of my phase shift. I know I need to pick it up and move it backward by 2, right? So this is going to be, the start is going to be x is equal to -2, okay? And the stop for my one squiggle, or in this case, my one Karate Kid, right? It's going to stop at -2, the same thing as my start, plus a period 4. So I know that my graph is going to be moved to the negatives by 2, which means it's going to start at -2, okay? And then it's going to stop after one period, 4. So it's going to stop at +2. Okay? Okay. So we're getting a little closer now. We have everything now. We have everything in front of us to start the graphing process by hand. Okay? So what I'm going to do is this. I'm going to actually... So what I'm going to do is this. I'm going to move this over a little bit. So let me actually come right there. I am putting down my x and y. So this is going to be my x-axis, and this right here is going to be my y-axis. Okay? I'm just putting it down so that we know which one is which. Okay? I know this one looks a little thicker than the rest of them. I didn't mean that to happen. It just did. Sorry. Okay, so we have everything that we need right now. Okay? All right, here we go. We know our graph. Okay? Let's actually start with this. Let's start with the midline. So you guys see the midline? it is y equal 3. So I'm going to go ahead and do 1, 2, 3. Here's my y equal 3, right? I'm just going to add my dotted line to signify that this is my vertical shift. This is going to be my midline, right? Okay. My graph needs to start here, right, at x equal -2. I'm going to actually write in my tick mark here, x equal -2. And it needs to stop, whoa, didn't go far enough back, right here. There we go. -2, okay? And it needs to stop at +2. So -2, so that means every 2 squares is going to be 1, 0, 1, 2, 3, 4. And when you're graphing this, you can break down your x-axis however you see fit. I'm doing it by 2 so I can give myself enough space. That's it. That's the only reason. Okay. If you wanted to do 1 square is equal to 1, that's fine. That's perfectly fine. Okay. All right. So let's see. I'm going to grab a green marker here, right? We've taken care of start at -2, stop at +2. So we know that our graph is going to have to start here and end here. Okay. We took care of our midline. That's the purple line, right? We technically took care of our period when we did the start and stop, right? Because the distance from here to here, this entire distance right here, right? That is 4. So that's all taken care of, right? Now all that's left is for us to slap down the actual graph itself, okay? Okay, so you guys remember those 5 points? There were 5 points. And I'm going to scroll over to the right here, just so I can show you guys what 5 points I'm talking about. For sine graph did this, right? It was this one. It was squiggle, right? And then for cosine, it was Karate Kid. It's this one. Okay, there were 5 points. 1, 2, 3, 4, 5 for sine. And then for cosine, 1, 2, 3, 4, 5. These are the 5 points that we're going to now try to slap down. Okay, and in particular, since in this case we are talking about a cosine graph, we are looking at these 5 points down below. Okay, so let me scroll back over to the left to our graph. Okay, I know this thing should have an amplitude of 2, so that means I'm going to go ahead and grab my orange here. That from the midline, it should climb to and drop to. So if that's 3, it should climb to 5, and it should drop to 1. Okay? We have everything we need. Okay? So our graph, since it's a negative, it's going to be an upside down version of our cosine graph. It's going to be an upside down version of this one, right? So it's going to do this. I'm going to slap down the points for them, right? So it's going to start here, go up to here, go up to here, drop back down, and then drop back down. Okay, and then you can just connect the points, connect the dots like we did in kindergarten. Bam, 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 bam. And at this point, this is one period, right, of our function that's in highlighted yellow, right? And at this point, notice how you see the 5 points that I just slapped down, right? I can just continue the pattern, right? So it starts down here, it climbs back up, goes up, drops back down, drops back down, climbs back up, right? And you can just keep connecting the dots. And remember how I said that this thing keeps repeating, so keeps on going that way, and then this side keeps on going that way. We are done. We just graphed y equal -2 cosine of that stuff plus 3. All done. Like I said, this is going to take us a long time to get used to. Don't be shy. Use up all the paper that you need to. If you need to double check your work, Desmos is the thing to do it, okay? After this class, you are more than welcome to put these into Desmos exclusively, okay? However, I do need to make sure that you know how to graph these, you know how to recognize all the portions and pieces. You can basically determine its anatomy, right? Just from the graph without using a graphing calculator. I got to make sure that you can do that, okay? There you go, right? What comes up next is quick checks, and that is it. Let your questions come up after that. I know this section is going to be hard. It's going to be long. It's going to take a lot of thinking. So, take your time with it. Okay. If there are any other questions, please ask me during our quick check times or during my office hours. Besides that, happy studying.